Syntax builds the form we see. Semantics gives it meanings key. Connectives link what minds devise. Quantifiers range through truth and lies. Modus ponens strikes with might. Modus ponens flips the fight. Logic cuts clean, no shallow line. Through the long night, reason shines.
Previously, we discussed various valid rules of inference, which, when applied to true premises, always yield true conclusions. Note, however, that in general, if we swap the premises and the conclusion, the resulting rule may no longer be valid. For example, consider modus ponens, which states that from if P, then Q, and P, one may derive Q. If we reverse the conclusion and the premises, we would be claiming that from Q, one can derive both P and if P then Q, which is clearly invalid. This is because the associated compound implication is false when Q is true, but P is false. To see an example, consider the following instance where P, Chewy is hungry, Q, Chewy meows. Then modus ponens tells us, if Chewy is hungry, then he meows. Chewy is hungry, therefore Chewy meows. However, if we try to reverse this reasoning and say, Chewy meows, therefore Chewy is hungry, and when he is hungry, he meows. This is no longer valid. Chewy might just be meowing because you carelessly stepped on his tail. This is not surprising. Recall that valid rules of inference are built upon logical implications. However, to enjoy validity in both directions, we require a two-way logical implication, that is, a logical equivalence. If P and Q are logically equivalent, then in a deduction, we can derive Q from P, and vice versa, just as if we are allowed to replace one term with the other. Such a rule of inference is called a rule of replacement, and the underlying logical equivalences are sometimes referred to as laws. Depending on the convention adopted by an author, several symbols are frequently used interchangeably to express the same equivalence. In what follows, we list some commonly used logical laws. We begin with laws involving negation, conjunction, and disjunction. First, consider laws with a single connective. The double negation law states that applying negation twice yields the original proposition. The law of commutation and the law of association allow us to reorder and regroup terms in a conjunction or disjunction, respectively. Next, we consider laws involving two different connectives. The distributive laws describe how conjunction distributes over disjunction and vice versa, while the De Morgan laws explain how conjunction and disjunction interact with negation. We now turn to laws involving the conditional. The truth table shows that if P, then Q is logically equivalent to not P or Q. This is called the law of material implication. Note that the right-hand side involves only negation and disjunction. This allows us to apply previously established laws. For instance, if P then Q is equivalent to not P or Q, which becomes Q or not P by commutation, then not Q or not P by double negation, and finally, if not Q, then not P, again by material implication. Similarly, the negation, if P then Q, is equivalent to not P or Q. By De Morgan's law and the law of double negation, this becomes P and not Q. Finally, the biconditional can be expressed using conditionals and conjunction, and is therefore governed by the laws established so far. A few remarks on the terminology. Given the compound proposition, if P then Q, we can consider its negation. Not if P then Q, its converse. If Q then P, and its contrapositive. If not Q, then not P. The original proposition always has the same truth value as its contrapositive, the opposite truth value from its negation, and an indeterminate relationship with its converse. If P logically implies Q, we say that P is a sufficient condition for Q, and Q is a necessary condition for P. As an example of application, by applying modus ponens to not Q and not P in place of P and Q, and using the equivalence given by the law of contraposition, we obtain modus tollens. This explains why the rules of inference introduced in the previous session can be seen as variants of modus ponens. The use of rules of inference allows us to derive true conclusions from true premises. Mastery of their application, of course, requires training and experience. In the next session, we will briefly go through a few toy examples to get a feel for the process of deduction.
Shinla Tensei